Hi everyone, and welcome back to Casper's dApp Developer Series. Today we'll be writing our first smart contract. Let's jump right in. Install the package cargo-casper. Cargo-casper will prepare a runtime environment and testing framework, as well as build the smart contract basics for us so we can get started. Now to create a new project, run cargo-casper and then the directory you'd like your project to be in. I'll use my project. To begin writing the contract, open up main.rs within my project, contract, src, and main.rs. Start by deleting everything up until extern crate alloc. And we need to use the following crates. We'll need string, vec, btree-map, and toString. We will also need Casper types, and we will need the following types. We need key, CL type, parameter, entry point, entry points, entry point type, and entry point access, and we'll use all of these in our contract. Lastly, we'll use the Casper contract crate, and within that we'll use runtime and storage from contract API, and we'll bring in unwrap or revert. The first function we'll write is the call function, which is executed when the contract is installed. We'll use the nomangle attribute, which tells the compiler to use the name of the function as its symbol name, so it's easily accessible. Now let's write the call function definition. And we'll start by creating a new value that we'll just name value, and we'll get it from the named argument that was passed in with the deploy under the key message. Now we'll wrap this value in a uref, and we'll create a new set of named keys that we will attach to the contract. And then from there we will insert our new value into named keys. As you can see, our named keys object is a tree map of string to key, but our value reference is a uref, so we use .into to wrap it in a key. From within our smart contract, we want to be able to update the message after we've installed the smart contract, and for that we can create an entry point called update message, but for that we will need to add a parameter, so we will create a new vector and we will push on the new parameter message of type string. Now we can create a new entry points object, and we can add our update message entry point with our vector that includes the message parameter. Now we'll want to store our contract within the global state, so we'll set a new object stored contract hash and contract version to storage new contract. We'll pass in our entry points, the named keys of the contract, the package name, and the access uref. We don't need the contract version, so we prepend it with an underscore. Now, so that we may easily access it from the account we're deploying this from, we can put the key in the named keys of the account, and we'll just name it Hello World Contract. Just like earlier, a stored contract hash is a uref, so we need to use .into to make it a key. Now let's write the function to update the message. We'll create a new function that we'll call update MSG, and just like earlier, we'll use the nomangle attribute. The first thing we'll do, like within the call function, is get the named argument message. Now we need to get the uref of the message that's stored in the global state. For this we'll use runtime getKey and we'll pass in message, but we'll need to unwrap or revert, and then we'll need to convert that into a uref and unwrap or revert that. In the event that this key does not exist, it will revert. Finally, we can write the message that we passed in to the global state under the uref that we had used previously. That's all this contract will do for this video. Let's go ahead and compile it to WebAssembly. Head over to your terminal and go to your working directory. Now run make prepare. Now run make build contract. This will take a couple minutes to complete, but once it's finished, your output should look like this. You can verify this worked by going to a file explorer, going to your project directory, contract, target, wasm32 unknown, release, and you should see contract.wasm. That's all for this video. In the next video, we'll use Node.js with the Casper.js SDK to install our contract to the network, query our message, and update our message. Remember to subscribe and to hit the like button if you found this video useful. If you'd like to be notified when new videos are released, hit the bell icon below. I'll see you in the next video.